Okay, welcome back to 7.3. And what are we doing? We're sort of exploring fractions all over again. Excuse me, except now with variables involved. Okay, so we learned how to simplify fractions. Now we're going to learn how to add fractions with common denominators and also subtract fractions with common denominators. Okay, so that's it. Okay, so first we'll, look back at where we began all of this with arithmetic, adding fractions. So recall this process. We may have had something like 4/5 plus 6/5. Okay, and we were asked to add this. So how do I add this? Well, you add the numerators over the common denominator. Okay, so in the end, you'll have 4 plus 6 all over 5. And then 4 plus 6 is 10 all over 5. And then you can simplify. Okay, you can divide top and bottom by 5, but the way we want to do it now in polynomial land is to kind of do factorizations and remove common factors. Okay, so 5 over 5 is the same as 1 over 1. We get 2 times 1 is 2 over 1. Of course, 2 over 1 is just 2. Okay. We want to do the exact same thing now with polynomials. And so let's take a look. So there's number 4 in the book, 9x all over 24 plus x all over 24. Okay, so it's pretty easy when they have the same denominator. We'll look at other, different denominators in the next section, but for now, they'll always have the same denominator. So we're just adding the numerator over the common denominator. So it'll be 9x plus x all over 24. Combine like terms, so you simplify the numerator before you try to simplify the entire fraction. Okay, so simplify this first. 9x plus 1x is 10x's over 24. And then we could remove common factors. So I like to factor it completely. 24 is the same as 2 times, 12. Okay, and then we can remove a common factor of 2. Okay. Okay, let's keep moving on. Here's number 12. So yeah, 8 over x plus 6 plus 10 over x plus 6. Okay. We have a binomial in the denominator, but it's still the same idea. They're the same. Okay, so we're just going to borrow that as our common denominator, x plus 6, and then add the numerators. So I have 8 plus 10. You want to simplify that numerator before you start thinking of anything else. And now there's no common factor in the top and bottom. Okay? You would need an x plus 6 in the top to cancel out with this x plus 6 in the bottom. Or you would need some factor of like a 9 here, or a 6, or an 18, or a 3, something like that. And we don't have it, so this is our answer. Okay. Let's try 18. Okay. So again, we have the same denominator, so we're going to add the numerators over the common denominator. Okay. Combine like terms, so 1y squared plus 1y squared is 2y squares. Negative 2y plus 1y is negative y. And that's all over y squared plus 3y. Okay, and then we try to simplify. So to simplify, as you noted up here, how did I do that? Well, I factored, and then I removed common factors. That's pretty much how it's supposed to work down here as well. So you add the numerators over the common denominator, combine like terms, so we simplified, and now we want to factor and remove common factors. So in the top, I can remove a y, and I'll be left with 2y minus 1. In the denominator, you can also factor out a y. You're left with y plus 3. Then y over y is same as 1 over 1, so you're left with 2y minus 1 all over the factor of y plus 3. And that's it. Okay, so addition, hopefully it's not too hard. The subtraction, a little bit extra, just a small bit, not very much though. So let's take a look. You have to distribute a negative to the second numerator. Okay, so you know, before this wasn't an issue, but now it's going to be. So let's just dive in. Okay, so here's 28, 2y plus 1 all over 3y minus 7 minus y plus 8 all over the common denominator of 3y minus 7. Okay. So when we, you know, the bottom's the same. You just borrow the same common denominator as usual, business as usual. The numerator starts out kind of the same. So you have 2y plus 1, the first numerator. But then you need to subtract the entire numerator. So you may even want to put parentheses around it to remind yourself. I have to subtract everything in here, not just the y, but the y and the 8. So indicate that with a parentheses. Okay. And then our next step, we're going to distribute that negative to both terms. Okay. So now we can go ahead and simplify, and what do we get? We get 2y minus y is y, 1 plus minus 8 is minus 7, and that'll be all over 3y minus 7. Okay. These are prime binomials, so you can't factor anything, and they're not the same, right? So this would have to be 3y minus 7 for it to cancel with the denominator, and it's not. So let's keep on looking, see if there's any stones to uncover or, you know, whatever. So the fourth. Okay, so I have something that looks like a cubic expression. Whoops, so I forgot the other term. Minus 7x cubed minus 3 all over 2x to the fourth. Okay. So same program, I guess. We're going to borrow the common denominator here and rewrite it here. And then I have x cubed minus 3 minus 7x cubed minus 3. Okay. So I need to distribute this negative. And I have x cubed minus 3 minus 7x cubed, and then plus 3. Okay. So you have to distribute, again, you distribute the negative to every term. Okay, so here I go, 3 minus 3 is 0, and then I'm just left with x cubed minus 7x cubed is minus 6x cubed, all over 2x to the fourth. If you want to, you can factor that, but 6 over 2 is the same as 3 over 1, and then x cubed all over x to the fourth is just the same as 1 over x. Okay, so in reality, we end up with negative 3 all over x. If you don't see that, I can always go ahead and factor the heck out of this. So it would be negative 1 times 2 times 3 times x times x times x, all over 2 times x times x times x times x. So there's 3 factors of x and 4 factors of x down here. 1, 2, 3, 1, 2, 3. From the x cubed over x to the fourth, you're just left with 1 over x. And then the 2's will divide out. And you're just left with the negative 1 times 3 for the negative 3, and then the 1x in the basement. Okay. One more, and then we'll move on to opposite denominators. Okay, so again, we have a common denominator. We're just going to borrow that denominator, so y squared minus 16. In the numerator, I'm going to distribute this negative through all three terms. Okay, so I'll have, if you want to, first write it minus the entire numerator, and then I'll distribute my next step. Okay. I combine like terms now, so 2y squared minus 1y squared gives me 1y squared. Those guys are done. 6y plus 3y is going to give me 9y's. Those guys are done. 8 plus 12 is 20. And that's all over y squared minus 16. Okay. Sometimes you can simplify these. I don't think we can well, maybe we can. Let's try. So set up your parentheses. It has to be plus plus. Okay. And then something times something, that's 20, but adds to be 9. So I think that's 5 and 4. Oh, we are going to get a nice cancellation, huh? So the bottom is just a difference of squares, so it would be y plus 4, y minus 4. Then these are the same, so we can remove them. And we're left with y plus 4, oops, I mean y plus 5, all over y minus 4. And then that's it. Yeah, so always check at the end, make sure you can, make sure you've gotten it simplified completely. Every once in a while you'll make a mistake, but just give it a look over. And make sure you're not accidentally forgetting something. Okay, so section 3, subtracting with opposite denominators. And what do we mean by opposites? We mean additive opposites. So if you're to add the denominators together, you would get 0. Okay, so for instance, number 40, we see that. We have 6 all over x minus 5 plus 2 all over 5 minus x. Okay, so look at the denominators. They look like they're almost exactly alike. The only problem is this is positive x, this is negative x, and this is negative 5, and this is positive 5. So they have opposite signs, and there's a quick trick for this. Okay, so if this happens, you can immediately replace the plus sign with a minus, and then rewrite the denominator on the second term. Okay. And clearly then 6 minus 2 is 4 all over x minus 5. Okay. So the theory behind the trick is interesting, but it's the kind of thing you'll look at once and then you'll never probably look at it again. You'll just always remember, okay, if there's an opposite denominator, I just reverse the direction and change the sign here. Okay, but let's see the theory behind it. Okay, so I want to change this denominator to look like this denominator. And one thing I can do is factor out a negative. So in the denominator on the second term, I factor out a negative. That'll leave me with negative 5 plus x. Okay, now I'm going to reverse the order of these two terms. Negative 5 plus x is the same as x minus 5. Okay. Okay, we're almost there. Now you can move a negative from the bottom to the front to the top. That's a common rule for negatives. So if you have a negative, for example, if you had negative 3/4, you could always rewrite it as negative 3 over 4 or 3 over negative 4. it looks a little bit weird when you have some variables involved. For example, if you had negative x plus 2 all over 3 minus x, in order to move that negative into the numerator, you need to include a parentheses because it will be the entire numerator negated. Okay, and likewise, if you moved it to the denominator, you would have to change the sign of everything in the denominator. So you need parentheses to indicate that. And that's kind of what we have going on here. Okay, it's kind of just like this. So we can pull that negative out in front, but we can also pull that negative in top, put it in top. It's really up to you. Okay? Okay, so anyways, in this problem, we want to move it in front, and we'll have 6 all over x minus 5 plus this negative in front of the fraction, negative 2 all over x minus 5. Okay. And then at the end of the day, well, for example, if you had 3 plus negative 5, we know from arithmetic that we can write that equally as 3 minus 5. Okay, so here I have 6 over x minus 5 plus negative 2 over x minus 5. I can rewrite that as 6 over x minus 5 minus 2 over x minus 5. And, you know, long story short, that's exactly what I did just by saying, okay, just reverse the direction of the denominator and change the signs, or whatever I said. Okay, okay, so hopefully that works for us. Let's take a look at apparently a whole bunch more of these. This is 42. Okay, so I got 6x plus 5 all over x minus 2 plus 4x all over x, 2 minus x, sorry. So rather than going through the theory, now we'll just apply the rule. We don't want to have to reinvent the wheel every time we do a math problem. So what did we say? We need to change the 2 minus x and the x minus 2. And then we change this sign from plus to minus. So this will now be a minus. And then from this point on, it's just like a problem from before. We just, you know, borrow the common denominator and subtract the numerators over it. So 6x minus 4x is 2x. And then I think we're stuck there. Let's get another. Okay. So again, these denominators are opposites. So we'll change the direction of the second denominator, make it y squared minus 16, and then change the original sign in between the terms to a minus. Now I want to subtract the numerators over the common denominator. Distribute this negative. And I have 2y minus 14 all over y squared minus 16. Let's look at 54. Okay, opposite denominators again. So reverse the direction. This will now be y minus 4, so it doesn't look like a... y minus 4. And then change the sign from minus to plus. Add the numerators over the common denominator. And that's it. So these kind of look like maybe they're opposites, but they're not. This is the case where they're not opposites because they don't all have opposite signs. So y and y have the same sign. Plus, minus, yeah, those are different, but they all have to be different. If this was negative y plus 4 and y minus 4, then they would be opposites, and you would be able to simplify. It's just two more. Whoops, and then plus x minus 2 all over 30 plus x minus x squared. Okay, so these are opposite denominators. 2x plus 3 all over x squared minus x minus 30. Change the sign in between them. Downstairs now I have x squared minus x minus 30. Subtract the numerators over the common denominator. Don't forget to include those parentheses. Distribute. Okay. 2x minus x is x. 3 plus 2 is 5. And I think we might be able to simplify that one. This denominator looks like it will factor into an x plus 5 times x plus something, or x minus something. So set up your parentheses. The signs have to be plus minus. And then I'm thinking 5 and 6. So the 6 has to be negative. And sure enough, it'll simplify. So we just have 1 over x minus 6. Let's take a look at one more. This will be 67. Okay. Looks a little different. So there's two ways you can attack this. You can distribute the negative first, or you can just combine the terms inside the parentheses. Let's combine the terms inside the parentheses. So I'll have 2y all over y minus 5 minus, they have a common denominator, so I'm just going to add the numerators over that common denominator. Okay. And so our new numerator, 2 minus 2 is 0. We just have y over y minus 5. Then subtract the numerators over the common denominator. And that's it. Okay, see you next time.